Okay, class.
So this is part 2. We need to know what is a double box plot and a double dot plot. Okay. Um, there. So here's an example. So this is a double box plot. So when you are explaining, so double box plot, two box plots on the same number line. And then I used example 1 like I told you over here. So you will draw this picture in your book. The picture for example 1. And what is the data I got from the first one that says math class? The minimum is 0, the maximum is 30, Q1 is 5, Q3 is 20, and the median is 10. So there, the minimum is 0, the maximum is 30, Q1 is 5, Q3 is 20, median is 10. I did the same thing for science. Minimum is 0, maximum is 30, Q1 is 15, Q3 is 25, and the median is 20. So that's the data I got from my double box plot. So let's look at the double dot plot. And I said I went to example 2. So I go to example 2, and this is example 2. And you draw this, please. Make sure you draw this in your blue book, the pictures. You write the title and you draw, just like that. So the two dots are on the same number line. So the two dot plots, so you have the Springfield and the Lake City, and you have one number line because this is the one with the numbers. So you come here and you get your data. This comes with the first line like that. Use your ruler to make sure you get the correct number like that. Or draw a line, draw a vertical line connecting the dots together with the line, the numbers in the other number line. So here is my data from Springfield, and here is my data from Lake City. Okay? All right, so now you know how to draw the double dot plot and the double box plot. Okay? You'll have two number lines, but one of them will have the numbers. Okay? All right, now let us do example A. Now, before we do example A, we need to know, we've already discovered how to identify if your data is symmetric or non-symmetric. Okay? If your data is symmetric, if both of them are symmetric, not one, both, that means they look like this. If both your box plot looks like this, equal parts, then you need to do the mean and the mean absolute deviation. If your data is symmetric, both of them, remember you're doing 2 because you say double. Double means 2. If both of them are not symmetric, then you must do the median and interquartile range. Symmetric, mean and mean absolute deviation. Non-symmetric, median and interquartile range. If one of them is non-symmetric, you must do median and interquartile range. Okay, so let's look at the example 1. So we are comparing what Lamia did. Lamia surveyed a different group of students in her science and math classes. The double box plot shows the results of both classes. Compare their centers and variations, write an inference you can draw about the two populations. So you're doing two things. Where is my pen? Here. You're comparing, this is very important, and you're writing an inference. So you must do these two things. Okay? So we have information about the math class, and we have information about the science class. Okay? So both of them are non-symmetric because the left and the right, they don't look the same. Here is the middle. The left does not look the same. So both are non-symmetric. So step 1 is you find whether they are symmetric or not symmetric. Okay? That is step 1. You first determine whether they are symmetric or not symmetric. Okay? So both of them are non-symmetric, so that means I will do the median and interquartile range. So I found the median of the math class, it is 10. And I found the median of the science class, which is 20. Then I found the interquartile range, which is Q3 minus Q1. The same thing here, Q3 minus Q1. So 20 minus 5 for math and 25 minus 15 for science. So I'm going to look at 15 and 10, okay? All right, so we are comparing, what did we say? The median for the science class is twice the median of the math class. And the median and the interquartile range is greater for science, no, is greater for math. The interquartile range is greater for math because 15 is greater than 10. Okay? Now, what is the inference I can make? There is a greater spread of data around the median for math than for science. That is my inference. Here I have compared. This is comparing and this is the inference. From here to here is the inference. Let's do our example A. Let's see how we can do ours. So I am comparing who? Electronic world and bargain basement. We are comparing the cost of MP3s. These people are selling MP3s, okay? Now let's see, is our data symmetric or non-symmetric? Our data is non-symmetric. So step 1, you write non-symmetric. And because they are non-symmetric, I will do median and I will do interquartile range. Median and interquartile range. Okay, so example 1. Where is my example A? Okay, here is my example A. So I drew my table. Electronics world, bargain basement, median, and interquartile range. So I came here. The median for electronics world is 70. The interquartile range, I took 65 and I took 75. So 75 minus 65 is 10 and my median is that. My median for the basement is 60. My interquartile range will be 65 minus 55, which is 10. Okay? Now I want to compare the centers. We shall compare the medians because the medians are the centers. Why? Because our data is non-symmetric. Okay? So the median price for the electronics world is greater than the median for the bargain basement by 10. Or I will say 70 is greater than 60. Just like that. 70 AD because it is money. Okay? Now I want to compare the variations. What will I compare? I will compare the interquartile range. So when you're comparing, you must do the median and you must compare the interquartile range. Okay? So the interquartile range for electronics world is the same as that for the bargain basement. Each is 10 AD. There you go. All right. Now the question said, write an inference about the two populations. The MP3 players sold at the electronics world are more expensive compared to bargain basement because the median price is higher where? Is higher at electronics world. So you will spend more money at Electronics World than in Bargain Basement. So I would buy my product from Bargain Basement because it is cheaper than if I went to Electronics World. That's what I'm saying. And then you write here 70 AD is greater than 60 AD. There. Okay. So I have answered question A. I have shown you, you have to write your table. This table is the beginning. After you've determined whether your data is symmetric or non-symmetric, then you draw your table, then use your table to help you to answer. Okay? Let's do example B. Example B is about Abdul Rahman and Tariq. Okay, so let's go to Abdul Rahman and Tariq. You will read example 2 by yourself. You will notice it is, what is it? They are both symmetrical. You see? They're both symmetrical. The left is the same as the right. So if this is my median, this side is the same as this side. The same thing here. This is the middle of my data. This side looks exactly the same as this side. So this data is symmetrical. Symmetrical. Since it is symmetrical, I will use the mean and the mean absolute deviation. Mean absolute deviation. Okay? Which they did. They did the work, and this is the values that they got. I have already shown you how to find the mean. I have shown you how to find the mean absolute deviation. Okay? And what did the question say? Compare. The question wants us to compare, and it wants us to write an inference about the data. So, according to example 2, you compare. You notice that the mean in Lake City is greater than the mean in Springfield, but they have the same variation. Okay? So, while both cities have the same variation, the spread about each of their means is different. Lake City has a greater mean than Springfield, which means the temperatures in Lake City are higher than the temperatures in Springfield. So let us look at example B. We have Abdul Rahman and we have Tariq. If I look at my data, it is non-symmetric, because if I say the half is here, the left does not look like the right. The same thing here. If my half is here, the left does not look like the right. So non-symmetric. Non-symmetric. So that means I will use the median and IQR. Those are the two things I will do. Okay, so here, since it's a dot plot, I will need to get my data for Abdul Rahman and my data for Tariq. So here is Abdul Rahman's data. I wrote it out, all this. Then I found the median by crossing out. I have two numbers in the middle, and then I did this, I divided by 2. So here is my median. Because my data is non-symmetric, so that means I needed to find my median and my IQR. Then I came here and I found my lower half and my upper half. Then I found my median for my lower half, which is this. I got 34 emails because I crossed out like this. I was left with 2 numbers in the middle. And then I added and divided by 2, and then I got that. I did the same thing for the upper half, like that. And then I found the IQR. And this is what I got. Okay. Then after I did Abdul Rahman, I did Tariq. I did the same thing. I wrote my data out. I found my median. I found the median of my lower half and the median of my upper half. And this is my work, as you can see. And then my IQR was that. And this is my answer for the IQR. So after I found Tariq's data, Abdul Rahman's data, what did I do? I made my table so that it is easier for me to answer. So I did Abdul Rahman, Tariq, I wrote the median and IQR for Abdul Rahman, and the median and IQR for Tariq. The question wants me to make inferences. We can draw. So I made 2 inferences. There is a greater spread in Tariq's data for new emails than in Abdul Rahman. Why? Because Tariq's has 4 and Abdul Rahman has 2.5. 4 is greater than 2.5. I wrote it over here. Okay? There's a greater spread in Tariq's data for new emails than in Abdul Rahman's data because Tariq's IQR is greater than Abdul Rahman's IQR. 4 is greater than 2.5. Okay? Abdul Rahman's center is greater than Tariq's center because Abdul Rahman's median is greater than Tariq's median. That's the same thing I wrote. Okay? There you go. Now, what is the inference? This means Abdul Rahman gets more emails and will get more new emails than Tariq. Because the median is high in Abdul Rahman, it means Abdul Rahman will get more emails. Okay? And there we have answered question B. You must do all the steps. You must. You see how much work we did? We did Abdul Rahman's work. Then we did Tariq's work. Then we used the answers we got to make decisions. That is what you will be expected to do in this lesson. Okay? Now, let us look at example C. Okay? You will read this by yourself. Example 3, you will read by yourself and do. Alright, example 4. Okay. As you notice over here, this is non-symmetric. This one is non-symmetric. Non-symmetric. Or non-symmetrical. It doesn't matter. Non-symmetrical. And this one is symmetrical. So, I told you if one is non-symmetrical, then you must do median and IQR. Okay? That's what we must do in this one here. They did it for you. You need to do and check if their work is correct. The same thing here. These ones are both non-symmetrical. No. Not both. This one is symmetrical. See, you have to be very careful. This one is symmetrical. And this one is non-symmetrical. And because this one is non-symmetrical, we must do median and interquartile range. Because one of them is non-symmetrical. Okay? So I want us to do example C. So what do I have? This is symmetrical. And this is non-symmetrical. I told you, this is step 1. There's an M over here. This is non-symmetrical. non-symmetrical. Okay. Alright. So since this is symmetrical and non-symmetrical, we will do median and IQR. That's what we will do. Median and IQR. So I did Ali's data. That's Ali's data. I found the median of Ali's data. I found the IQR of Ali's data. I got 2. I did the same thing for Omar. So this is Omar's data. I found the median. Okay. Then I found median of my lower half, which is my first quartile. And here is my IQR. Okay. I did the third quartile, first quartile, like that. All right, what do we do next? We make our table. Here is our table. You write median IQR and you write Ali, Omar. You write their values from your work. See? Median for Ali is 18. IQR for Ali is 2, which I wrote over there. Omar's median is 17. And Omar's IQR is 4. I wrote it over here. Okay. What does the question want? As I read, I underline. The question wants me to compare. And it wants me to answer which runner is more likely to run a faster race. Okay. So I'm comparing the centers and the variations. Okay. Ali's median is greater than Omar's median. 18 is greater than 17. Omar's IQR is greater than Ali's IQR. 4 is greater than 2. What does this mean? This means Omar does not run consistently. If you look at Ali's data is around 16 and 19. So he will get a number between 16 and 19 all the time. Omar, he is running all the numbers on the time. Today is running 14, tomorrow is running 15, another day is running 23. His numbers are all spread out widely, you see? He's using the whole number line. So that means he is not consistent. He's not getting this around the same time all the time he's running. Okay? So this means Omar does not run consistently. His time changes a lot of times. And there is a big difference between his run times. Every time it is changing, okay? All right, now we need to answer which runner is more likely to run faster. What does running faster mean? Running faster means you took less time. Not that you took more time, you took less time. If 2 people are running, let's say Shaker and let's say Shaker, Arwa, and Shahad. Okay? Shaker runs how much? Let's say Shaker runs 10 minutes. We are running 100 meters. Okay? Shaker runs 100 meters in 10 minutes. Arwa runs 100 meters in 12 minutes. And Shahad runs 100 meters in 8.5 minutes. Shahad is winning the race because she used less time. So number 1 will be Shahad. Number 2 will be Shaker. Number 3 will be Arwa. The less time, the faster you are. Okay? So, running faster means less time is taken when running. So who took less time? Omar. So Omar runs faster. Okay? So Omar has the lowest median. This means he will take less time to finish a race. And this means he ran faster. So, finish Aleph, your DOKs. And do your guided practice. Do number 1, 2, and 3. This way, you know if you understood. So tomorrow we will start with number 1 and 2. Okay? All right. See you tomorrow.